Well, greetings, Mr. Kolazar's class. Our last section of our math review is going to be on dimensional analysis. Now, dimensional analysis is going to be a problem-solving technique to convert between different units. So it's going to be kind of a fraction-based idea coming up, or a conversion-based idea between one unit and different units. Now we'll use this a ton coming up in chapter 10, 11, and actually continuing on. So we need to get this system down now so we can use it in the future. Now, one of the key parts to this is an idea, shown below. Let's say you had 293 quarters. So this is what's known or is given to you. So this is known or given. It's your starting point. Known, given, or starting point. And what we want to do is to go from quarters to, say, dollars. Now, what we already know is that $1 equals 4 quarters. But we want to figure out every time correctly, do we need to multiply or divide in order to go from our beginning unit, quarters, to our ending unit, dollars. And so our conversion that we know is that $1 equals 4 quarters, or 4 quarters equals $1. So we know $1 equals 4 quarters. So we want to be able to set these up so our units can cancel. So quarters unit on top and quarters unit on bottom can cancel each other out, leaving us with our new desired unit, dollars. So in dimensional analysis, we're going to need to know these conversion factors. So there are a lot of conversion factors out there, one thing equal to another. So some examples we just did: 4 quarters equals $1. If you have a dozen, you'd have 12 eggs. 1 inch equals 2.54 centimeters. This is going to be a good one to know, just in general. So it's our metric to English conversion. 100 centimeters would be 1 meter. And 1 mile, we got a lot of different conversions for a mile. 5,280 feet equals a mile. Another one we could even add in, 1.61 kilometers is the same as a mile. So you could add that one in also. All three of those would be equal to each other from our English to metric conversions. Add these ones in too. 1 meter equals 1,000 millimeters, or 1 kilometer equals 1,000 meters. So those are just a couple extras. Add these ones in, because those will be useful as we're going forward also. So now our conversion factors are a key part. A number of interest is multiplied by a conversion factor to cancel out the current unit and convert to a new desired unit. So an example would be if you wanted to go from feet to inches, we would set up 12 inches is 1 foot. So our conversion factor between those, we could set that up 12 inches over 1 foot, or we also have 1 foot over 12 inches. So we need to set it up correctly so that we can convert and have feet cancel feet to get us into inches. Numbers on top are going to be multiplied, kind of like thinking like a fraction, and numbers on bottom are divided. Now let's say you started off with and you had 48 inches. Now to make inches into feet, we would now use our second conversion. Inches, a unit of inches, 1 foot on top. 12 inches would go on the bottom. Inches would cancel inches, and we'd be left with feet. So in the end, 48, in this case, numbers on bottom are divided. So 48, don't worry about the ones, 48 divided by 12 would give you 4 feet. Now these are common units, inches to feet, quarters to dollars. We want to get this setup done correctly because we're going to start dealing with things like moles and grams per mole and molecular mass, terms that are not common to us in everyday conversions. Now, another setup is if we had like a unit like miles per hour or miles per minute, where we have information on the top and information on the bottom, or numerator and denominator. So 1.5 miles over, say, 1 minute. If we wanted to convert the fraction or the factor, and we wanted to change minutes into, say, hours, 60 minutes equals 1 hour. And we can set up so that the minutes on the bottom cancel the minutes on the top. If we multiply numbers on the tops, 1.5 or 0.15 times 60 divided by 1, don't need to write the ones or use the math in ones, gives us 9, and now it's 9 miles per hour instead of 0.15 miles per minute. So in the end, you can convert units that are on the top of the fraction or on the bottom. So our dimensional analysis, we're going to use a couple practice problems. If you have 56 quarters, how many dollars do you have? To help us out, underlining information we're given, how many dollars, and then circling information that we're trying to solve for. So we want to go from quarters to dollars. So 56 quarters. Now this is what is given to us, given or known. This is going to be our starting point. And what we're trying to get to is to go from quarters to dollars. Our conversion, quarters to dollars, $1 equals 4 quarters. So we want to set that up. $1 equals 4 quarters. So quarters can cancel quarters. Numbers on top are multiplied, 56 times 1. And if we divide that by 4, in the end, we get about $14. So as we're going, converting between one unit and the other is our dimensional analysis idea. Now these examples, remember, we're setting up basic ideas now so that we can get to our more complicated ones, but they're still set up the same. If you have 96 eggs, how many dozen is this? And remember, 12 eggs equals 1 dozen. So our starting point, 96 eggs, is what we're given, so that's our start. And we want to set up a conversion factor so that our units can cancel. So 12 eggs over 1 dozen. So in the end, as we're going, this time 96 times 1, don't need to do that in the math, divided by 12. And in the end, that's going to be 8 dozen, would be how many eggs we have. So numbers on top are multiplied, numbers on bottom are divided. So Mr. Kolazar is a whopping 71 inches tall. All right. And so what we're going to look at is, how tall is he in meters? So to do this one, there is no conversion right from inches to meters. However, if we wanted to go back, we could go inches to centimeters, and then once we're there, we could go centimeters to meters. So this is going to be a two-step process. We're starting with inches, and we want to get to meters. So we know that 1 inch equals 2.54 centimeters, and we know that 1 meter equals 100 centimeters. So those are the two conversions that we're going to do. Now the other nice part about dimensional analysis is we can do this all in one step. you can do more than one thing together. So our starting point, 71 inches, is where we're going to start. And we want to go from inches to centimeters. Need to set it up so that the inches can cancel inches, leaving us with our new unit, centimeters. And then we can go from centimeters to meters in our second step. 1 meter equals 100 centimeters. And this can all be done in one step. So on your calculator, we would set it up just going 71 times 2.54 divided by 100, and in the end we get about 8. Oh, what did we get? 1.8034. Now we start off with 71, 2 significant digits, so 1.8, rounding 0 to 8, and so 1.8 meters, significant figure measurements, would be our answer there for our practice. Our last problem for today: if a jug of milk is leaking at 0.025 liters per minute, what is this rate in milliliters per second? So we're changing from liters to milliliters and seconds from minutes. So our starting point, what we're given, 0.25 liters. And our second step now is divided by minutes, or per minute. If you want to, you could put 1 in here. It's the same idea, liters per minute, liters over minutes. I just put 1 in here just to show it's every minute 0.025 liters is being leaked out. So we want to go from liters to milliliters. We'll start there. So our conversion to go from liters, 1 liter would equal 1,000 milliliters. So we'll set that up. 1 liter will equal 1,000 milliliters. Why did we put it this way? So our liters can cancel our liters. Now our second step is we want to go from minutes to seconds. Conversion there, 60 seconds equals 1 minute. Now we want to set that up so that our minutes can cancel. So 1 minute equals 60 seconds. Minutes cancel minutes. And if we were to think about this like one large fraction, numbers on top are multiplied, numbers on bottom are divided. So in the end, we could put all 3 parts together. Alright, so we could put those 2 parts together. 0.025 times 1,000 divided by 60. And in the end, we get about 0.411 or 0.41666667. So in the end, we started out with 2 significant figures. So in the end, we will end rounding up to 2 significant figures. Our units left over, milliliters per second. Now as we're going to start using units that are not common to us, like milliliters and liters, but like moles and grams. So we're going to be familiar with how we set these up is our important part here.